All right. Good morning, everyone. Welcome to this fourth webinar of the Nordic Green Building Councils. We are streaming live today from Reykjavik, Iceland. My name is Sigurður Bjarnadóttir, and I will be moderating today's webinar. I am an associate professor at the University of Iceland within the Civil and Environmental Engineering Department. I also sit on the executive board for the Icelandic Green Building Council. I myself have been researching climate change in the built environment for the past 13 years or so I'm very excited to hear today what the Nordic countries have to say about climate change and climatic adaptation. In my opinion, it's extremely important that we learn from one another, hear what we are doing in all these countries to make sure that the Nordic region maintains its place at the forefront of sustainability within the built environment. The Icelandic Green Building Council is the smallest of the Nordic councils. We have one employee, but we have 55 members. To undertake and prepare for this webinar, we in Iceland have had a lot of help from our colleagues in the Nordic countries, and we would like to thank everybody for their efforts and help in preparing this webinar. The topic of today's webinar is resilience and climatic adaptation. The outcome of the IPCC report last fall was clear. Even though mankind does everything it can to meet ambitious goals of climate reductions, I should say carbon reductions and carbon neutrality, we can no longer prevent the negative impacts of climate change. We must act now to prepare ourselves for future challenges the best we can. The webinar today consists of 5 presentations from Iceland, Finland, Norway, and Denmark. First, we will learn a little bit about the content of the IPCC report on climate change from Dr. Guðfinna Aðalgeirsdóttir, but she is one of the lead authors of the report. We will hear from Miisa Tähkänen from Finland. She will tell us a little bit about how climate change effects differ between regions. Dr. Kim Paus from Norway will discuss the principles of climatic adaptation for urban rainwater and sewage systems. Alexandra Hansson from Denmark will discuss how climate adaptation played a role in an actual project in Copenhagen. And then finally, Sigurður Freyr Jónatansson will tell us how a scenario approach to baselines for the assessment of actions towards resilience and climatic adaptation is used in the finance sector. All right, so it's a pretty interesting webinar today, so let's get started. First, we have Dr. Guðfinna Aðalgeirsdóttir. She is a professor of glaciology at the Institute of Earth Sciences at the University of Iceland. Her research focuses on the interaction of climate change and glaciers or ice sheets by monitoring and modeling the response of glaciers and ice caps, present, past, and future. She's done fieldwork in Iceland, Alaska, Switzerland, Greenland, and done 2 field seasons in Antarctica. She is one of the lead authors of the working group's 6th assessment report from the IPCC, contributing to Chapter 9, Ocean, Cryosphere, and Sea Level Change. Welcome, Guðfinna.
Hello, everybody. I would like to thank for this opportunity to speak about the report that just came out in August. It's the first report out of 3 in this assessment cycle of the IPCC, the Intergovernmental Panel on Climate Change. And this was working group 1 about the physical sciences, but working group 2 and 3, they will publish their reports in February and March this year, and a synthesis report will come out at the end of the year. So there's a lot of reports, but it's a very important topic. And the message of this first part, the physical science, is really clear, and it has not been changing very much since previous reports. The recent changes in the climate are widespread, they're rapid and intensifying and unprecedented in thousands of years. The CO2 concentrations is the highest in the atmosphere in at least 2 million years. The sea level rise is the fastest in at least 3,000 years. And the Arctic sea ice on the northern hemisphere is at the lowest area extent in at least 1,000 years. And the glaciers retreat is now unprecedented in at least 2,000 years. So we have a very interesting and very alarming situation in the atmosphere currently. And the message is also very clear that unless there is immediate, rapid and large-scale reductions in greenhouse gas emission, limiting warming to 1.5 degrees will be beyond reach. And this is the goal of the Paris Agreement. So we really have to be putting more effort into our reductions of CO2 emissions in order to be able to reach that goal. Also, another very clear message from the report is that it's indisputable that human activities are causing climate change, making extreme climate events, including heat waves, heavy rainfall and droughts, more frequent and severe. And in such a short time, I will not be able to tell much about what's in the report. I think the message is very clear that in many regions, in many aspects of the climate system, there are very rapid changes. One thing that is new in this report is the interactive atlas. The location or the web location is shown here to the top right. And you'll see that the world is split up into regions. And I'll talk about the regional fact sheets a little bit later on, where drawn out of the report is regional information for each of those parts. So I recommend having a look at the interactive atlas. It is possible to select what future we are heading towards and see what the consequences are for different variables. So it's very easy and should be very accessible to have a look at what the climate report actually has currently in the projections. And the projections for the sea level have also been taken up by NASA, and NASA has made this sea level tool in order to make those predictions available and accessible for people who are interested in knowing what the future has, given the different scenarios. And just to emphasize that human influence has warmed the climate already. The warming since the Industrial Revolution, at the end of the 19th century, is already 1.1 degree. And the rate of warming is unprecedented in at least 2,000 years. There are a lot of different consequences, and here we focus on the hot extremes. This is a figure out of the summary for policymakers, and the red boxes, one for each of the regions of the globe that I showed before, shows that there is increase in hot extremes, and the dot below the region names indicates the confidence. So 3 dots below Northern Europe shows that there is high confidence in increase of hot extremes in that region. And a similar figure for heavy precipitation shows also increase with very high confidence for Northern Europe region. This is also shown in the factorial in the regional fact sheet that I show later on. So what about the future? There are a set of 5 illustrative emission scenarios were considered, and you'll see that there are 5 shown here. 2 are blue, those are the low and very low. That means that emissions have to be cut immediately. And the blue shows a rapid reduction, and the light blue even more rapid, very optimistic, that expect a net CO2 removal in the atmosphere by 2050. And the red, the medium and the high and very high emissions show what the consequences could be if the reductions are not happening as rapidly as our optimistic predictions make. And global warming of 1.5 degrees and even 2 degrees will be exceeded during the 21st century unless deep reduction in CO2 and other greenhouse gas emissions occur in the coming decades. So we don't have much time. And all those 5 scenarios show here what the consequences are for the global surface temperature. And the low and the very low emission pathways show that we will be very close to 2 degrees, 1.5 degrees, almost certainly, unless the reductions are very rapid. Just a picture showing what the consequences are for the Arctic sea ice in September. And it will become practically ice-free mid-century unless we follow the very low and the low emissions scenarios. And one of the big consequences that are important, especially for the built environment and for everybody living close to the coast, are the sea level rise. That is a result of both the expansion of the ocean as it warms, but also additional water coming from the melting glaciers. And those are acting on very different spatial and temporal scales. And here is the projection for the sea level rise. The sequence of the 5 emission scenarios are shown here. So depending on what the emission scenario will be, the sea level rise could be anywhere between 0.5 and 1 meter. But a new thing in this report is that we take also into account low likelihood but high impact storyline in case the ice sheet, particularly the ice sheet in Antarctica, will start collapsing and maybe even adding to the sea level rise faster than we can predict with current models. And the same figure here, looking a little bit into the future, up into 2300, it is clearly shown here in this figure that it makes a really big difference that we follow the Paris Agreement and don't reduce the emissions as fast as we can, and don't follow the business as usual scenario shown here with red, that is extended up to a 15-meter sea level rise by 2300 in the case of this low likelihood, high impact scenario. And now to the regional fact sheets. Those are available on the IPCC website. And I'll just show a few figures here from the Northern Europe fact sheet about heat and cold. The future levels of the warming will rise in all the European areas, and those are similar to the past observations. The frequency and intensity of hot extremes will increase, and the frequency of cold spells and frost days will decrease in those scenarios. Also for the sea level, it will be rising everywhere in Europe except maybe in the Baltic Sea, and snow and ice is declining in this region. And more detailed look at the very northern part of this European region is also showing that there are several other consequences that could be expected, and they are dependent on the scenario, the emission scenario that we will follow. So I thank you, and I wish you good discussions in the emissions in this webinar, and all the information in the report is available online.
All right, thank you for that, Guðfinna. It's so important that we see these results from the IPCC, but I can't say that it's very uplifting. I mean, it shows the reality of what we're faced with now, and how really important it is that we are working together, both to reduce obviously carbon emissions, and also to make sure that we are prepared for the changes that are going to come. And that brings us into the next presentation. We have Miisa Tähkänen, who is a leading expert from the Green Building Council in Finland. Her field of expertise includes life cycle analysis, circularity, and business development. She's currently working on several international projects, such as the Nordic Network for Construction, dramatically reducing embodied carbon in Europe, #BuildingLife, and life levels. Today, she will talk to us about climate resilience and climatic adaptation. She will hopefully help us answer the questions: what does it take for a city and its inhabitants to adapt to climate change? And how do we better prepare for the world of tomorrow? Welcome, Miisa.
Hi, and thank you for having me here today. My name is Miisa Tähkänen and I'm from the Finnish Green Building Council. I'm here to talk to you about adaptation to climate change and resilience to climate change. But first, a couple of words about the Green Building Council. We're Finland's most extensive cooperation network for a sustainable built environment. We have around 250 organizations as our members and around 400 of their best experts work in our working groups and peer-to-peer learning groups. This is because our mission is to cooperate in front of vicious problems such as climate change and find solutions for them together. I want to talk about climate change and adaptation to climate change from a bit of a different point of view. So we've heard today already how the climate will change globally. The natural changes are quite dramatic and our nature is pretty much endangered, but so is also the comfortability of our lives. Later today, we'll hear some presentations about more technical solutions that we can apply to help mitigate the risks related to climate change. But I want to bring to your attention some different kinds of risks. We here at this event are professionals of the building, construction, and real estate sectors, and we know that the change in the climate will affect our real assets. But what we don't really know is how climate change will affect human behavior and how the changes in human behavior will affect the value of our assets. To understand how climate change is changing the world, we'll need more than just good models aimed at predicting temperatures and storms. We'll also need to figure out how to predict what people will do in response to climate situations, including whether people view a change in their climate as good or bad, or maybe something in between. So first, I have a couple of pieces of terminology. So the difference between adapting to climate change and climate resilience is that adaptation is an active action. So it's anything we do purposely to mitigate the risks of climate change. We change the way we act, we change the way we build buildings. These acts are usually determined by reason, so we can tell in advance what we're going to do based on scientific data. Now, resilience, on the other hand, is a more passive internal property of a system. So it's a kind of flexibility and ability to bounce back and take any change that's thrown at the system. Human beings are incredibly resilient by nature. We can get used to any kind of changes in our living conditions and survive, but how human beings will adapt is not always explainable by reason. It's actually incredibly difficult to determine how human preferences will change in relation to climate change, and it's a topic that hasn't been studied a lot. We saw from the pandemic, for instance, that it was a risk that, even though it was a kind of risk that was foreseen in many ways, but nobody took it very seriously, so we weren't resilient and we didn't know how to adapt to it. But in 2 years, the way our societies worked changed significantly, especially the usage of buildings has changed a lot. Office buildings have suffered a lack of users, but as the pandemic is seen to be a temporary issue, this hasn't really affected real estate prices in Europe so far, but it has affected rent levels. But on the other hand, our expectations for our homes and residential properties have changed a lot. People are looking for larger homes further away from city centers. And as they no longer have to commute and they spend a lot of time at home, they're focusing on different things than they used to focus on. So in that way, the bigger change really didn't come from offices being banned. It came from human preferences changing. And even though the pandemic might be a temporary situation, it seems that some of the changes in human behavior might be here with us for a very long time. And these are the kind of changes that we have a very hard time foreseeing. Unfortunately, climate change isn't a temporary change in our environment. It's a change that will keep accelerating with time and keep getting worse and worse. And even though we currently know how the environment will change quite well, we have no idea how human behavior will change. On the next 2 slides, I've gathered some major changes in the climate that will happen in Finland. I'm sure these are rather similar to those in the other Nordic countries, seeing as we're located quite next to each other. But what I want us to do now is to participate in a sort of exercise of thinking. So instead of thinking about the technical ways that we can adapt to these changes, we'll try to imagine how they will affect human behavior. And in that way, we can maybe get a better idea about how product development, real estate development, and urban planning should adapt to the future. After all, there's no point in building buildings if nobody wants to live in them or nobody wants to work in them. This first slide that I have has all the changes that will happen during the summer period. And the first one we have here is major heat waves. So not only is the average temperature raising, but we'll also suffer large heat waves. And of course, first we think about heat island phenomenon, cooling, energy saving. These are, of course, good steps to take, but if we think a bit further, how will these kind of heat waves affect our behavior? How will this affect, for instance, construction sites, which are largely outside, or even the manufacturing industry? It could be that we start pre-manufacturing more in order to get the construction time on the site to be shorter, so that we'd have to work less outside. Then again, from like an office point of view, people might start like escaping cities during the summer, even more than they are doing now, because they can work remotely. Perhaps we'll adopt a kind of siesta-like tradition and start having breaks during the hottest time of the day just to get over the heat waves. Or even we'll have to spend full days inside due to UV radiation. The second major change we have is dry spells and risks of forest fires, which of course leads us to need to improve fire safety and irrigation to ensure our green infrastructure stays up to par. However, how will this affect human behavior? How will our urban leisure spaces adapt? Will we prefer blue infrastructure over green infrastructure in the future? And how could this affect urban planning? That's something to think about. Thirdly, in the summer, we'll have a lot more rain than we have now, especially in the south and west parts of Finland, which are the warmest ones. And this, of course, will lead to flood risks and storm weather and also bevel rain. Our buildings are quite well built to stand bevel rain because we have it already now. But as it will be more frequent, the cycle of maintenance will become tighter and we'll have to start repairing more often to take care of these issues. However, if we think about human behavior, this might affect migration, for instance, if areas become less, or people appreciate certain areas less, maybe especially those who can work from home, maybe they'll relocate to a bit of a better area to live in. And how will this affect real estate values? In the winter, we have a set of different problems. So the heavy rain will continue, but it will come down as snow, which will lead to us having to build our buildings more sturdy to take a better and a heavier load. Also, the freezing melting cycle will be more frequent as our winters become less reliable. And this again will lead to us having a tighter maintenance schedule, as the wear and tear will be a lot larger in the buildings. But how will human beings adapt? It's possible that we will adapt a kind of American culture of snow days where going outside is such a hassle that some days of the year we decide not to go outside at all. Maybe even school will be arranged online during the worst winter storms. The second change is something that personally will be really difficult for me to adapt to, but because the snow will come very heavy at times, but then leave again. So the freezing melting cycle will be more frequent. It will also increase darkness during the winter. So from a technical point of view, we might have to increase lighting, especially outdoors, and ensure that the temperature of our lighting mimics natural light and so forth. But we have no idea how this will actually affect human beings. Given the choice, people might not want to live in very dark areas, especially if they don't need to live in cities anymore. And maybe our working life will adapt. I've seen now during the pandemic that a lot of people like to exercise in the middle of the day so that they see the sun a bit. They might, take a long lunch break and go for a run and so forth. Maybe this could be something that could keep going on after the pandemic and become a new normal, just so that we can get over the darker periods in a more healthy way. This is a very important issue to consider as the increasing darkness will become a bigger and bigger mental health issue with time. And the last change I have here is the risk to seas and water courses, which of course vary a lot depending on the region and by the year. The increase in temperatures will create larger waves. And currently the situation is that we're gaining land every year due to the fact that the previous ice age put a lot of pressure on the land. And as the land is slowly getting back to its original situation or its original level, we're gaining land on our shores every year. But due to climate change, this direction will change and the water level rising will sort of take back the shore. So we're returning to the point where we were decades ago. And this might affect real estate values, for instance. But also if you think about a human behavior point of view, currently people pay more for seaside apartments. But in the face of these kind of risks like sea level rising and flooding and so forth, maybe people will start paying less for seaside apartments. Will people stop wanting to live by the seaside due to safety issues? We don't really know. It's actually impossible to say exactly how human beings will adapt to the changes. And it's in our nature to sort of think that everyone will react just as I would react myself personally. But it's worth taking the time to analyze and figure out what megatrends in city development will emerge due to climate change. This could help product development, and this could also ensure that buildings we build today and cities we develop today will be interesting also for the humans of the 2050s. But that's all from me today, and I hope you got some new ideas from this. I want to leave you with this quote from Sitra, which is a Finnish think tank. They define resilience as the ability of people and communities to act in a changing circumstance, to face and recover from disruptions and crises. For example, a society's ability to recover from war or nature's ability to restore balance in an ecosystem. When you think about human safety, management is successful if the operations are adaptable to changing situations and circumstances. So the attributes we really must apply to ourselves in order to become more resilient are flexibility, elasticity, and the ability to recover. Life as we know it won't be the same anymore due to climate change, but that's something that we have to accept and look into the future to see what our possibilities could be like. Some changes we will be able to foresee, but others will be a lot more difficult. It's really important to view change in climate together with change in society to make sure our businesses are resilient throughout the crises. But that was all from me today. My name is Miisa Tähkänen, and I want to thank you for your time. I hope this presentation was interesting for you. And if you want to discuss sustainable development or climate resilience or even circular economy, don't hesitate to contact me through the details given on this last slide.
All right. Thank you so much, Miisa. I think it's very important exactly that we highlight the effect climate change will have on human behavior. And if we are really to create sustainable development, sustainable cities, we need to account for this in our way forward. So thank you very much. Next, we are now going to kind of take a little bit more of a technical dive into some of these civil infrastructures. We have Kim Paus here. He is an associate professor at the Norwegian University of Life Sciences. He has a background as a stormwater consultant and has been involved in master plans, theme plans, and strategies related to the urban water management, climatic adaptation, and the development of blue-green infrastructure in Norwegian municipalities. Paus's research interest includes topics within interdisciplinary approaches to urban stormwater management, urban water quality, and participation runoff modeling. Welcome, Dr. Paus.
Thank you for that introduction. So in this presentation, I will try to briefly explain what challenges climate changes and stormwater runoff gives us, and also how we can cope with these challenges. So to understand the challenges, we need to know a little about how stormwater has traditionally been managed in urban areas. So from ancient times, we used a pipe system to transport both sewage and rainwater in a so-called combined system. The oldest part of our cities still have such system. And this system has many weaknesses. We built a so-called separate system from the 1970s. And in the separate system, sewage is carried in one separate pipe to the treatment plant, while stormwater goes in another pipe and is carried to rivers, streams, and fjords. And this way of dealing with stormwater has given us a number of challenges. For example, we can look at how runoff from a particular rain event is affected by traditional development. So by replacing forests and wetlands with roofs and asphalt, we not only get more runoff, but the runoff peak increases and comes earlier. So as mentioned, we built a drainage system to transport the runoff away from our urban areas. So everything below the red line is, so to speak, transported safely away. The problem now is that those who designed and built this drainage system, some of it over 100 years ago, could not predict the development we had until today and is planning for in the future. And this means that more often we experience rain events that result in runoff volumes that does not fit into the drainage system. And these volumes, represented by the area above the line, have great potential to damage buildings and infrastructure. Furthermore, many of the pipes are very old. They are filled with roots, stones, and twigs and do not have the capacity they once had. So we haven't taken very good care of the drainage system over a long period of time. And one obvious reason for that is because it is a hidden service, you might say. And it is difficult to see the needs before it is too late. The result is that the capacity is no longer given by this red line, but is at a lower level that will continue to fall if we don't intensify renewal of the pipe system. The consequence is more frequent storms that will damage buildings and infrastructures in our cities. And finally, we have climate change. And the latest estimates, at least for Norway, shows that the intensity of these heavy showers could increase with up to 50%. So climate change kind of acts in the same way as the other challenges. More water, which we not have control of. Fortunately, there is a solution to these challenges. In fact, we know how we can cope with this. We need to bring back nature-based principles into our cities. So this is kind of representing a shift on how we approach water in cities. It's really a paradigm shift from traditional stormwater management towards a more sustainable and climate-adapted management. So we no longer focus only on quantities, volumes, and discharge, but also on water quality, and not at least the resource water can be for us humans. And the main idea is to move away from a fast transport to drains and pipes and over to an approach where stormwater is managed at the very origin, where the rain hits the surface. So in order to cope with these principles, we use so-called step strategies when designing systems for stormwater management. And here you can see some of the various versions of these step strategies that I've collected. And in what follows, you will get my interpretation of this strategy. So rain events is divided into 3 steps with increasing amounts. So for a specific property, we will in step 1 have measures that capture, evaporate, clean and infiltrate runoff from small and normal rains, such rains that occur most of the time. Then in step 2, we will have measures that delay and retain runoff from the heavy rains. As shown, we must also utilize the small capacity we have in the existing drainage system. The volume we need to retain in step 2 is the difference between what comes in from precipitation and what we can allow to discharge into the drainage system. And finally, in step 3, we will ensure that runoff from extreme rain events is transported away as safely as possible from our urban areas using safe, convenient channeling. So let's look at some concrete examples to make it more clear. So let's start with step 2. So in step 2, we need volumes that are usually empty but can be filled with runoff during heavy showers. A popular solution is to place large pipe below ground. While this solution satisfies the need for stormwater retention, it is nevertheless below ground and therefore hidden from us. So we have to be a little careful. If this is not operated and maintained sufficiently, it will be like trying to solve the problems with the same mindset as the one that created the problems. So an alternative is also to place this volume above ground, in other words, using solutions or measures where we can see the water. The surface water or the surface-based solutions give us additional qualities that we can enjoy every day, such as aesthetics, biodiversity, and recreational values. So another type of measure which is emerging as the battle of available urban areas is increasing is so-called controlled flood areas. In other words, areas that has one function on a daily basis, but can also function as a retention system during the statistically very few days with heavy showers. So a large part of our cities obviously consist of roofs, and there are several solutions here as well. In this photo, you see a so-called blue-green roof on Vega Scene in Oslo, Norway. And the roof is actually designed to hold back the rain event that occurs once every 20 years on average in the future climates. So if you go back to our system, we can use the 3-step strategy to set some requirements for step 2. In other words, each property must in principle have volumes that are available to collect and retain runoff from these heavy showers. So let's now move on to the next step. In step 3, we must try to ensure that runoff from extreme rain events is transported as safely as possible through our cities using canals and depressions. However, we do not have to wait for the heavy showers to decide where the runoff will go. We currently have terrain data tools that can predict the flood paths with rather high precision. So we typically see these blue lines appear in places where we do not expect, that is, places where we haven't actually observed any water. Nevertheless, and more often, we get rain events that are so large that they verify these hypothetical blue lines. With other words, we don't have to wait until these heavy showers occur. We can act right now. So the approach in step 3 is to plan for where water can be transported. The roads are obvious measures, and we must decide which roads to use, with other words, where the water can be directed so that it does the least damage as possible. So another measure is also to reopen the buried waterways, that is, reopening small streams that were put into pipes half a century ago. In addition to ensure a safe transport path for runoff, the measure will obviously give or provide many other qualities. So back to our system, step 3 implies that we need a new layer of infrastructure, which consists of a holistic network of waterways that convey the runoff from the urban areas and to the river and fjord. And then finally, we have step 1, which in my experience is what is often most forgotten. So in step 1, we have the opportunity to do something with the daily rain. An example is a green extensive roof. They are quite thin and probably not the answer to climate adaptation. For example, they will not be able to hold back the rain associated with step 2. At the same time, every raindrop that hits the roof will be given an opportunity to have a different fate than ending up in the drainage system. It is also in step 1 that we can utilize infiltration and thereby bypass water from the drainage system. Infiltration is a rather slow process that we do not always dare to include when considering management of the heavy showers. And finally, it's in step 1 we have the opportunity to deal with pollutants in stormwater. If we construct a rain garden, for instance, to manage step 1 rain, we will actually be able to clean most of the runoff during the whole year. So jumping back to the 3-step strategy, we've seen some examples on how this strategy copes with our challenges. However, to achieve these 3 steps, it is absolutely critical that water is included as an important part of the early planning process. My experience is that it's rather hopeless to cope with these principles if the footprints of buildings, roads, and other infrastructure is already set. So we need a step 0, which represent the early planning process. So to illustrate this step 0, we can imagine the following situation. A developer is planning to develop a property. The x-axis shows time and some milestones, that is, when zoning plan is completed, when general permission is granted, and finally when permit for construction is given. And on the y-axis, we can put the number of possibilities the development project can have. So in the beginning, very little is determined, and we have many possibilities, of course. And as we progress in time, the possibilities are narrowed, and in the end, we end up with only one outcome, which is what is actually being built. So then one can ask, which of these project possibilities overlap with sustainable stormwater management? Well, my experience is that it's rather difficult to say. Sustainable stormwater management is not very well defined, and this overlap may feel like a very hazy cloud. So we can look at some examples to illustrate this issue. So in this system, runoff is conveyed from impermeable surfaces, roof and asphalt directly to the drainage pipe. And this is obviously not sustainable. So what if we build a buried detention basin? Will it then be sustainable? Or do we need to use water as a resource? For example, reuse some of the water for watering vegetation and thereby reduce water consumption? Furthermore, do sustainable stormwater management have to infiltrate water? What if we manage the water on the surface, utilizing its aesthetic values? Is it then sustainable, or do we need at least some vegetation to call it sustainable? Finally, is it only with green roofs and bioretention cells, along with the use of multifunctional areas, that we can actually achieve sustainable stormwater management? So we could go on forever discussing such issues, but what we need is somewhat agreement. So this hazy cloud can be more defined, so we can determine which of the project possibilities that appear to satisfy sustainable stormwater management. So when the borders are defined, we can implement step 0 in the early planning process. And by that, I mean determining how much area we need for stormwater management and where to put it. Hopefully, by doing this, one can influence the project to such an extent that we ensure that the final outcome will have a stormwater system consistent with the ideas of the 3-step strategy. So, of course, we could have discussed several issues along the timeline here, from this planning stage and to the final construction stage. However, today I'll skip this and we'll focus on 2 concluding remarks. First, we see major fails in the phase where the measures are being constructed. I will not show any examples here, but one typical experience is that we fail to get the water into the measures. Canals are not designed correctly, the slope is in the wrong direction, and there's a lack of inlet construction in the measure. In the worst case, this means that all planning and all costs are totally wasted. We can only hope that this is something that gets better as we gain more experience constructing these types of measures. And the second remark is a reminder that the job is by no means completed once development is built. In fact, this whole planning process is just a tiny moment in time. We really need to take into account that the measures must be operated and maintained for many, many years to come. In addition, as mentioned previously, if we are able to strive for sustainability, we must realize that the future is highly uncertain. For example, the climate we expect is highly uncertain. And of course, there will be new technology and new opportunities and new challenges that are impossible to imagine today. So we must really expect that what we today understand as sustainable stormwater management can change over time. So this means that we must have measures that are flexible, as mentioned previously. In other words, measures where it is possible to change their sizes, function, areas, depth, etc. In short, the measures we build today must be able to be altered so that they can satisfy the need we do not know. Thank you.
All right, thank you so much, Dr. Paus. That was very interesting. All right, so before we jump to our next presentation, I just want to tell everybody we're probably going to run 5 minutes over, just so everybody knows, but you can always go back and look at the complete recording of the webinar if you're running late to another meeting or something like that. But anyway, we're going to keep on this down this track of stormwater management. Next, we have Alexandra Hansson. She has 17 years of professional experience as a landscape architect at sLAB, delivering interdisciplinary urban development projects of both a physical and a strategic nature with a strong focus on sustainability. Additionally, Alexandra is a certified DGNB consultant on urban areas, and she is responsible for SLA's R&D department, sLAB, where she runs the studio's national and international research collaborations, as well as the studio's professional development across the field of nature-based design, which she will tell us a little bit about today. The presentation will take us through SLA's approach of nature-based thinking and practice by looking at the SLA prototype cases. Welcome, Alexandra. Thank you.
And thank you for inviting me. So yes, I'm Alex, and I'm from SLA, and just taking you through our approach to nature-based design. And just a brief introduction to SLA. We are an interdisciplinary design studio that does nature-based design. We are 130 and a learning and sharing organization on a mission to create better conditions for life. And when we say life, we mean all life. So we are biologists and anthropologists and landscape architects and many disciplines to work on this nature-based design. We strive to connect people with new nature and to make nature and its processes a vital and integrated part of urbanization. So for those of you who might not know us, this is Copenhagen, which got a lot of attention recently, winning an award. We are so happy. And we did the project together with BIG. The design is nature-based, and connecting people to nature with wild plants, rockscapes, ski slopes. 7,000 bushes and 300 trees are planted in up to 80 meters altitude. But the important thing is to bring Copenhageners closer to nature and nature experiences. So what is our thinking and mission and my role in this lineup today? I will tell you a little bit about our thinking and show you an operational tool we did with colleagues in a think tank. And finally, a project in Copenhagen that we think and see as a prototype on climate adaptation. But first of all, the thinking. Until today, nature has been separate from the city. That was the general assumption and the way that we used to do city planning. However, a nature-based city solves urban challenges and really creates life quality. And as we understand today by the presentations, it's something that we all have to participate in. And to put it into a well-known context, this is the wedding cake diagram for the SDGs, where the biosphere is the foundation of all life. And we sometimes seem to forget this fact. So how to make this thinking operational? SLA was chosen in 2016 to facilitate a think tank consisting of experts from different fields to develop a solid framework for Copenhagen's green identity and urban nature before doing the 300 climate adaptation projects and spending billions. So I guess it's Kim's step 0. Here you have the key values that the think tank and the municipality of Copenhagen decided upon. For this presentation, I think the first and the last is maybe the most central, because Copenhagen's green identity is urban nature, nature-based, and will change Copenhagen and create better conditions for life. This, I think, is a very big and very important decision that the city of Copenhagen made, that they actually want to do this model that Kim went through, or try to make that the model. We developed in this think tank the Copenhagen model, and it was introduced as a concrete development tool that promotes and qualifies the decision making in all of the phases of a project. and ensure that the planned 300 climate adaptation projects will be nature-based and connected to urban nature. And if you sort of elaborate on the model, on the left side, you have the utility values like CO2 reduction, air quality, rainwater management, cleaning water, urban heat island, and noise reduction. And on the right side, you have the amenity values like community, sensing, learning, belonging, identity. And what we have found, as you see in the middle, we put the ecosystem service by biodiversity. And we have found that if you put biodiversity first, the design often performs on all these ecosystem services and values. So in our thinking and in our projects, we often put biodiversity first. And what is really nice is that you can actually assess the value of these ecosystem services, all the benefits that nature does for free, and connect nature to the business model, because that's very often, of course, very important, that we can argue why this nature-based approach is worth anyone's while. So just to go through the recommendations, we think it's very important to develop strategy and supporting tools, build knowledge about the state of nature in cities, map the distribution and condition of urban nature, also have the courage to describe that all projects must improve urban nature quality, and of course monitor effects over years and set measurable criteria of success. And I think we also need a bullet that has to do with management and maintenance. So now I will show you the project. It's called Bryggervangen and Sankt Square. It is Copenhagen's largest and greenest cloudburst project so far, and a cornerstone in Copenhagen's climate district. I have to say that we were the designers and lead consultant, but we did the project together with Miras, Via Trafik and Jens Rørbæk. The contractor was Ebbe Dalsgaard, and we did it for the municipality of Copenhagen. Okay, so project info. The project is situated in Østerbro, which is in the northern inner city of Copenhagen. Here you see the climate district and the project area of 35,000 square meters. Here are the design concepts, or big moves, you can call them, how to handle the rainwater, actually create new nature, create synergies with local initiatives, reorder traffic in order to create space, and of course maximize green by removing a lot of asphalt. Actually, we removed 9,000 square meters of asphalt in this project. This is before, where you of course see a lot of asphalt, and this is the after. And one of the main points of doing this climate adaptation and doing it where the rain hits the ground is to make space for nature in cities. This is another picture. I think it's really amazing that you can make an infrastructure and climate adaptation project into something that feels like a forest, and that people experience the aesthetic sense of nature in everyday life. We know that that does a lot of good. Again, a before picture, and how to create a new setting that enhances quality of life. You can see that there are new social opportunities, days, meetings, places to gather, nature experiences, and a destination in a roundabout. That's kind of funny. But what it does is that it creates a real neighborhood. So of course, it's a network of green rainwater beds that can contain volumes and enables the urban space to handle everyday rain, daily rain, to the service level that Copenhagen has set. I think it's a 10-year rain. And adding the streets even handle intense cloud bursts going 600 to 7 liters per second. And the water gives life to plants and trees, as well as creating new blue-green nature experiences right in the middle of the city. And the design, of course, increases biodiversity in the city. It functions as a dispersal corridor, or you can say a green infrastructure, between the nearby parks, in this case, Fælledparken and Kildevandsparken, and it's designed to give home to local flora and fauna. We planted about 600 trees and kept approximately 30 out of 60 existing trees, which I think is okay, considering that we did a lot of terrain work to handle the water. And you go from this before picture, we love those pictures, to a green lush street. And my main point is that if you can transform a roundabout to feel and function like a forest, anything is possible. Thank you.
All right, thank you so much, Alexandra. It's wonderful to see a practical application to climatic adaptation and how it's playing its part into your actual projects. Looks to be beautiful. All right, so we all know that the built environment is a huge investment, both for ourselves personally and for our Nordic governments. So our next speaker is Sigurður Freyr Jónatansson. He's from Iceland. He graduated as an actuary from the University of Copenhagen in 1997. He started working for the Icelandic Financial Supervisory Authority in 2002 and is currently working at the Central Bank of Iceland. He has been active in the fields of climate change and sustainable finance in recent years, both within the Central Bank of Iceland and internationally. He will be responsible for the climate scenario analysis of the Icelandic financial system, which is scheduled for release in 2022. Today, he will discuss why scenario analysis is important to understand the likely and possible economic and financial consequences of climate change and climate change policies. Now, I'm going to switch with him, so don't go anywhere. Welcome, Sigurður.
Okay, hello everybody. Due to interest of time, I will go directly into the topic, and the first topic is why climate change scenario analysis is important. Traditionally, we have stress testing of the financial companies. They are a test on how certain scenarios will affect the balance sheet of financial companies, and in some cases they are used to calibrate capital requirements. The aim of such stress test is to see how feasible it is for the companies themselves and supervisory authorities to respond to and prevent adverse stress. In regard to climate change, the financial market has less resources to prevent the consequences. So in that case, we talk more about scenario analysis. And there are two main types of risks that are two types that are used in the financial sector. One is transition risk, which is the consequences of government policies to prevent climate change risk and move to a low carbon economy. The second is physical risk, which are the direct consequences of climate change. That could be flood, hurricanes and forest fires, etc. So why is it important to make scenario analysis? Central banks make all kinds of predictions for the economy, like inflation, etc. In climate, we have to think many decades ahead, especially regarding physical risk. And all predictions are bound to be estimates. This is a difficult task, but it's a task that cannot be ignored. And it's important for the central banks around the world to get a picture on the risk to financial stability. And we have to make sure have to understand that the scenario analysis is not a prediction, it's a storyline that we tell people what could happen in the future. Let's then move to short introduction to Nkfs. It started as a coalition of 8 central banks and supervisors. They established this network of greening the financial system, and its purpose is to help strengthening the global response to meet the goals of the Paris Agreement and to enhance the role of the financial system to manage risks and to mobilize capital for green and low-carbon investments in the broader context of environmentally sustainable development. Now we have little over 100 members in this network, and at COP26, the chairman of the network said that it started as a coalition of the willing, but now they are a coalition of the committed. So this is a very important network. And the reason I'm talking about this network is that they have defined scenarios that are common, should be a common international ground. And they are based, for example, on the same model that are used in the IPCC. And we have these 4 quadrants. The first quadrant on the bottom left is orderly transition and low physical risk. This is the optimistic scenario where we can meet the Paris Agreement without too much transition risk. On the top left, we have disorderly transition. We meet the Paris Agreement with very much difficulties. We start only maybe in 2030 to change the policies, and that will lead to disorderly transition. In the bottom right quadrant, we have so-called hothouse world, which is there will not be many changes in policies, and that will lead to very high physical risks. On the top right quadrant, we have a very pessimistic scenario, which is where we have a high physical risk, which lead to very high transition risk. And those high-level scenarios are used to create Nkfs scenarios. They are coordinated and available on a public portal. And the aim is to encourage the authorities around the world to estimate the climate risk in a similar way. And the scenarios can also be used by the public and the financial market participants. And they are under constant development. Last time they were published was in June 2021. Since then, we have had a new IPCC report, and we also have had COP26. So we expect that in June 2022, the new scenarios will reflect that change. And so it's also possible to use own assumptions on top of those scenarios. Here we can see how the scenarios are situated on the scale. And we have two scenarios for each 3 of the, you can say, realistic quadrants. And we have, like in the hothouse world, we have NDCs, which stands for nationally determined contributions, which means that it's the pledges of the states around the world. Here we have a graph that shows the effect of carbon price in Iceland. Basically, it shows how much it have to cost to use carbon to reach the goal of each scenario. In the bottom, we have a red line which shows NDC for Iceland, nationally determined contribution. And there, in that scenario, it doesn't cost very much to use carbon. But if we will have to meet the Paris Agreement, we have to, it has to cost more to use carbon, and especially in the disorderly scenarios, it costs very much. So this is an indication that disorderly transition is not good for the economy. And Nkfs published a report in October on how supervisory authorities and central banks are using the climate scenarios that Nkfs has published. 31 members participated, amongst them the Central Bank of Iceland. And here we can see what has been published. In October, France, Italy, European Banking Authority and European Central Bank had already published. I know that since then at least Canada has joined, and several others have published a report on scenario exercises. And Iceland is one of the countries that are planning a scenario analysis. Here we can see one example of the scenario analysis that has been made from the European Central Bank, which made the analysis on the largest banks in Europe. And we can see that they compare it to the net zero 2050, which they used as a so-called baseline scenario. And we can see that for the firms that are customers of the banks, we can see that hothouse world, the red line is very bad. And also the disorderly scenarios, disorderly transition is also bad, the yellow line. So this shows very clearly that disorderly transition is not good for the economy. Finally, I will go a little bit through what is the plan for the Central Bank of Iceland. For this year, we will mainly focus on learning from this exercise. As I mentioned in the beginning, it's not the purpose of scenario analysis regarding climate change to make any decision about capital requirements or any other decision on that area. But we will use the exercise to get some overview on the effect on the economy and financial market. In the beginning, the main focus will be on the credit risk of banks, and in that area we will look at mortgage, real estate loans, and other loans to the building sector. Stress test and scenario analysis can be both made on data that the central banks already have, which is called top-down, or bottom-up. Bottom-up is collecting external data from the financial market participants. In the beginning, we will try to use the data that we have, and we will focus on both transition risk and physical risk. And we have already started discussions with other institutions, like the Meteorological Institute that we have already started discussing with. And if we look a little bit ahead, then in the future we will improve the accuracy of the scenarios. And some of the models that Nkfs is using do not currently apply to Iceland, so that is something that we are working on in cooperation with the model providers. And we will try to cover as many risks as possible and estimate the impacts on banks, pension funds, and insurance companies. And we will start to prepare data submission of the financial market participants. I will end with some references if the participants in this webinar are interested in looking at some of the reports that have been published. Here you can see the links, but you also can Google it if you want. So, and thank you for your attention.
All right, thank you so much. We've learned a lot today. Well, I have anyway. We've talked about resilience and climatic adaptation. We've talked about what's going to happen in terms of what the scientists are saying. We've talked a little bit about how human behavior might change. We've gone a little bit into the technical details of some of the engineering solutions that need to change with these changes that are coming. And then we also know now a little bit about how the financial sector is primed to kind of take these adaptation challenges to task. So I encourage you now to go back, figure out what questions you have maybe, and then maybe even reach out to the presenters specifically with questions. I would like to thank all the presenters today for wonderful discussions and presentations on their topics. Also would like to thank the Nordic councils and everybody who's kind of participated in making this webinar the success it was today. And then, I would just like to thank you all for viewing. All right, take care. Bye.